I'm editing a video and I need my shopping cart to turn upside down. So I need to tell the software where the final position of the shopping cart's going to be relative to the initial position. The initial position is 0 degrees. So in order to make it turn upside down, I'm going to make the final position 180 degrees about the z-axis. On second thought, I want to add some drama. I want the shopping cart to complete an entire revolution before it stops in the upside down position. To do this, it's pretty simple. I just add the revolution, or 360 degrees, to the original 180 degrees and configure the final position to be 540 degrees. Let's say I want it to go in the opposite direction, in the counterclockwise direction, rather than what it's doing now, which is going clockwise. To do this, I simply need to change the sign to make the final position negative 540 degrees. So now our shopping cart should complete 1.5 revolutions in the counterclockwise direction. Perfect. Let's take a look at the degree measurements that we just used. 180, 540, and negative 540. What they have in common is the final position of the shopping cart. But they differ in two major ways. The number of revolutions completed before landing in the final position, and that's designated by the value of the measurement. The second way is the direction of the movement, which is designated by the negative or positive sign in front of the value. Now, whenever we have a pattern like this in mathematics, we like to create some kind of general term to describe it. And the term that we use is coterminal angles. And in order to understand how coterminal angles fit into the study of mathematics, we're going to start with an example. Here we have an angle in standard position. This means that the initial ray lines up with the positive side of the x-axis, and the terminal ray represents the other boundary of the angle. We always measure an angle from the initial ray to the terminal ray, and the positive direction is actually counterclockwise. So this angle has a measurement of approximately 130 degrees. In this next example, we see the initial ray in the same position, but the terminal ray completes one revolution before settling into the same position as the first example. Using what we know from the shopping cart example, we can calculate the measure of this angle by adding 360 to the original 130 to get 490 degrees. Just like with the shopping cart example, we can also go in the negative direction, as you'll see in these next two examples. In the first one, we can subtract 360 from our original measurement of 130 to get negative 230 degrees. And in the final example, we go a full revolution in the negative direction before landing in our original position. And to calculate this angle measurement, we can subtract another 360 from that negative 230 to get negative 590 degrees. Since the terminal ray for each of these four angles in each of these four examples is in the same position, we call these coterminal angles. So now before we go, I have some questions for you. The first one has to do with convention. In our editing software, a positive angle meant a rotation in the clockwise direction. But in mathematics, a positive angle means a rotation in the counterclockwise direction. Why do you think this is? My second question's a lot more straightforward. Can you find the measurements of two angles that are coterminal with an angle that measures 20 degrees? And the final question, if you had an angle that measured 45 degrees, could you create an expression that represents the measurement of all its coterminal angles? Use the variable n to represent any integer. positive, negative, or 0.